Welcome back, class. In today's video, we're going to talk about the product rule. Now, what I've written here is the sum rule, which you may think is a mistake, but I want to review what the sum rule says first, so that we can understand what the product rule says and how it's different. What the sum rule says is that if you take the derivative of the sum of thing A and thing B, then what you get is the derivative of thing A plus the derivative of thing B. And so what does the sum rule really do? It tells us how to take the derivative of a sum of two things. From there, you can probably guess what the product rule is going to do. The product rule is going to tell us how to take the derivative of the product of two things. And so what the product rule says is that if you take the derivative of thing A times thing B, then what you get is the derivative of thing A times B plus A times the derivative of thing B. Note, this is a little more complicated than you would hope it would be. You would probably hope, oh, it's going to work just like the sum rule. I'm just going to multiply the derivatives of A and B. But unfortunately, that's not how it works. But now we do at least have this rule, so we can use this rule now whenever we come across a product. Now, I want to remind you, we did take the derivative of a product before. Namely, in section 3.5, I did this example, where I took the derivative of 2x plus 1 times 3x minus 2. And how did we do that? Well, the way we did it was to rewrite it so it wasn't a product. However, now that I know the product rule, I could instead choose to take the derivative of this using the product rule. And so I want to do that as my first example, just to show you a different approach. So when I do the product rule, I'm going to write out what thing A and thing B are. Okay. I recommend you do this as long as you're getting used to this. Maybe eventually you'll be able to do this part in your head. If so, that's okay. But for now, I'm always going to write this out like this. Okay. So thing A is the first thing, thing B is the second thing. And so the product rule is going to tell us what the derivative of the product of these two things is. But the product rule is going to require the derivatives of A and B. So I am going to go ahead and, before I go any further, write down the derivative of A and the derivative of B. Namely, the derivative of A is 2, and the derivative of B is 3. One way to think about this is that both A and B here are lines, and so the slope of the tangent line to those lines is just the slope of the line. But you can also see this through our rules that we've used so far. And so now, if I apply the product rule, what I'm supposed to get here is the derivative of A, which is 2, times B, which is 3x minus 2, plus A, which is 2x plus 1, times the derivative of B, which is 3. Okay, if I continue along this path, what do I get? Okay, well, this is going to be 6x minus 4 plus, and then this is going to be 6x plus 3. And so if I combine those, then I'm going to get 12x minus 1. Now, of course, I got the same answer, which is good, because this function should only have one derivative. And in this case, that derivative is 12x minus 1. And you could still do this question this way. Maybe you feel this was shorter than this new way, in which case, that's fine. But there are a lot of functions that we can't take the derivative of by just sort of multiplying it out until there's not a product anymore. And so I want to show you that there are now a bunch of functions whose derivative we can take with the product rule that we could not take before. Here's one example. I have a product here of x cubed and e to the x. and I want to know its derivative. There's no way I can simplify my way out of this so that I can avoid using the product rule. So I'm just going to use the product rule here, and I'll write down thing A, the first thing in the product, is x cubed, and thing B is e to the x. We'll go ahead and write down the derivative, which by the power rule here is 3x squared. And by our rule for the derivative of e to the x from the previous video is e to the x. And so when I follow this recipe, I get that the derivative of x cubed times e to the x is a prime, which is 3x squared, times b, which is e to the x, plus a, which is x cubed, times b prime, which is also e to the x. And that's it. That's the derivative of x cubed times e to the x. Now, for what it's worth, I'd accept this as an answer. But for what we're going to do next week, it's going to be really helpful if we get in the habit of factoring e to the x's out of things. So I'm going to write this for my final answer as x cubed plus 3x squared times e to the x. Again, I'm just doing this to get us in the habit for next week when we're going to do this a lot. Practice makes perfect, so I'm going to do a number more examples where I just apply the product rule for you, just so you can get very used to writing down what a and b are, and then using the formula to get your derivative. However, it would be most useful for you if, after I write up an example, you used this formula first to practice, and then look at my solution to see if you'd got it right, or if you screwed up a sign somewhere or something like that. The more practice you get with this, and the sooner you get that practice, the better shape you're going to be in for the test, and next week's test, and the final. Now, because of our earlier example, you might be tempted to multiply this out first, and then take the derivative. However, this is just a piece of advice. Almost all the time, when your function is written as a product of two things, it will be faster and easier for you to use the product rule first, and then simplify whatever is left over. So, in this case, for example, my thing A is going to be 3x squared minus 7x plus 2. And my thing B is going to be 2e to the x plus 5. A prime, then, will be 6x minus 7. Remember, the derivative of 2 is 0. And b prime here will be 2 times e to the x. The derivative of 5 is 0. Okay. Remember, when I take the derivative of 2 times e to the x, I just keep the 2, and then take the derivative of e to the x, which in fact gives me e to the x back. And now we're ready to apply the product rule. And so, following this little recipe that we have up here, we'll get that this is 6x minus 7 times 2e to the x plus 5 plus 3x squared minus 7x plus 2 times 2 times e to the x. And now all I have to do is simplify this. Now to simplify this, I really should multiply it out. Okay. So 6x times 2e to the x, that will be 12x e to the x, plus 6x times 5, that'll be plus 30x, minus 7 times 2e to the x, that'll be minus 14e to the x, minus 35. Then I do the same thing for this piece. So that'll be plus 6x squared e to the x, minus 14x e to the x, plus 4 e to the x. So now let's collect everything. So I'm first going to find all the terms without an e to the x in them. So I believe there are two, the 30x and the 35. So this will be 30x minus 35. And then I will go ahead and put together all of the terms with an e to the x. So plus 6x squared times e to the x. Then we have a 12x e to the x and a minus 14x e to the x. That is going to leave us a minus 2x e to the x. And then we have a minus 14 e to the x and a plus 4 e to the x. That will leave us with a minus 10 e to the x. And if I want to smooth that out just a little tiny bit more, I can write this like this. And you could even factor out a 2 if you want, but this is good enough. Okay, let's look at this example here. Here, I have a 2x plus 1 squared multiplied by a natural log of x. And so what I'm going to call my thing A is 2x plus 1 squared. And what I'm going to call my thing B is natural log of x. Now, I'm supposed to write down the derivative of A and the derivative of B. Well, the derivative of B, that's just a formula that we learned in the last video. It's 1 over x. However, I cannot just take the derivative of A with any of the rules if I write it this way. And so remember, if you encounter something like this, you still have to FOIL it out first. If you really want to, you could actually write this as 2x plus 1 times 2x plus 1, and then take the derivative of it using the product rule, but that's probably significantly more work than you really want to do. So, using this formula, we will get that A prime is 8x plus 4. And now we're ready to apply our recipe. So this is going to be 8x plus 4, which is A prime, times the natural log of x, which is B, plus, and then my A is 4x squared plus 4x plus 1, times, and then B prime, which is 1 over x. Okay, so I don't think I can really simplify this part unless I want to pull out a 4, but I'm not going to bother. And here, if I actually distribute this, it makes it a little nicer. Why did it make it nicer? Well, 4x squared times 1 over x, that's the same thing as 4x, plus, and then 4x times 1 over x, that's 4. And then, well, I can just write a 1 over x here. And so that, all together, is our grand answer for the derivative of 2x plus 1 squared times the natural log of x.